Hello, everybody. Welcome to episode 2 of the Svelte Way. We're back for more. I'm excited. Are you excited, Amelia?
I'm stoked.
Okay. Today's topic is some built-in Svelte motion stuff. So we're going to go over Svelte Tweened and Svelte Spring and kind of discuss some of the trade-offs, get a little deeper into how they work and why you'd use them, and maybe also show some real world examples of places we've used both. Anything else before we jump in?
Yeah, there's a ton of ways to animate things in Svelte. It's one of the benefits of using it as a framework. Um, these examples would be when you have a value that changes once, twice, however many times. It's not for like enter and exit animations, although maybe you could use it for that. But for that, you would typically use the built-in transitions like fly and fade or your own custom ones. So these are for values that change once, twice, many, many times.
Yep. Awesome. Let's jump into the code and get up and running. So we're going to start by introducing Tweens. It's, in my opinion, easier to grasp from the outset. So as you can see over here, and actually let me hide our second demo. First thing we're going to do is real simple. Let's say we have a number and we want to animate it as it changes. So like interpolate the number so it transitions from, like one of those, I don't know, those train boards or whatever where it kind of cycles through. There's a lot of real world examples. So all we have pre-coded here is a button that when we click it, it changes to a random number between 0 and 100. And then we have a little component called interpolated number where we pass that value. So if we jump into that, you can see all the stuff that's going on. So to use a tween, you have to import it from Svelte motion package, not just from the generic Svelte. I always forget this and always get an error. So it's specifically from the motion package. And I guess just some under the hood stuff, Tweened is a store, I think by default, like that's what it is. So if you're not familiar with stores, go check out like the store documentation because you kind of need to understand stores, but we'll be explaining how all that works here. So yeah, you can see we have that value coming in from the parent. And then a few things are going on here. First is the setup. So like I said, it's a store. So we create a new tweened thing here. We're calling it local value. And we set the default value at the outset on initialization. And then you can just pass it a couple properties, duration and delay. They're pretty self-explanatory. I don't know, and there's also easing, which we'll explain in a second.
One gotcha here that I've run into is it must be the way Svelte compiles, but you can't use let to define local value. Otherwise, it'll, I guess, create a new store every time, which I thought was weird.
I've never tried that. I always default to const, so I haven't had to, unfortunately, debug that. So let's see. So that's the store. You can see the only thing we're rendering out is the value of that store using the $ local value. And then all we're saying is when the value changes, so when the parent passes in that new generated number, we're calling the update local value function, which is simply just setting the new value of the tween store, and tween does the rest, and the magic and transition ensues. So without further ado, we click the button and we see it nicely interpolate between those two numbers, and it renders out the result at every update. So we get a nice little transition.
One of the reasons I really like this example is I think tweens can feel very magical when you first use them. So this is kind of just showing, literally it's just taking a value and interpolating between the current value and the next value. So if you're just rendering out as plain text for a number, it's just like on an interval updating from like 23, 24, 25 up to the next number.
That is correct. Also, because this is a store, we could actually make this way simpler. So we could actually just say, what is it? Local value dot set value. So this would actually fire whenever value changes. So same functionality, just much briefer, but we might want to do other things, except, or we can even just say, I suppose this, I'm assuming, will also work. So like everything, there's a few different ways to do it. But let's go back to this. So that's tweened in a nutshell. Should we get into easing?
Yeah, let's get into easing. So right now it's just defaulting to a linear easing. Yeah, it looks like that. So it goes, basically it says from A to B, we're gonna have even steps in between these two numbers and we're just gonna go through them. There's a lot of different easings that are actually built into Svelte, which is this Svelte/easing package. This is kind of a visualization of all of the different easings. It's a little bit overwhelming, but it's kind of showing you for this same transition, if you use a different easing, how do those look different over time from the beginning to the end? And you'll see some of them will even overshoot. So if it's going up to 70, it'll jump up to like 75 and then come back down.
Yep, like the backend is a great example. So it's really easy to use these in practice. Harder to see the results when it's non-visual and it's just the numbers, but we'll do it. So we have a couple in here. Actually, I like that one. I just saw back in. Let's try that one. So this is from the Svelte easing package, and you can just bring them all in or one at a time. So if we say easing, cubic, in, out, and maybe let's extend this so we can just try to see if we can see the effect. So you see it, like it took a while to start, then it ramped up a little bit, and then it slows down again. So it kind of follows that, whatever the cubic curve is. So starts, speeds up, and then slows down again. So if we go to back in, this now should make the number go in the wrong direction. Or nothing would happen. Oh wait, it was just a really long one. There we go. So that one ticked up a little bit and then it flew downward. So doesn't really make sense with this example, but that's kind of how the easing works. Anything else on easing?
Easings are great for like in the real world, things generally don't just happen in a linear fashion. Like if you want to move something, it might move slow at first and then really fast because it has that inertia or momentum. And then you might like overshoot it. So this is a really nice way to make things feel kind of more alive. Probably doesn't make much sense for this example, just when you're changing between numbers, but it can be really nice for things like position.
Yep. Oh, we skipped over delay. I mean, this one will be pretty obvious, but if we have a delay of a second, it's once we fire it, it's literally gonna pause for a second before it runs. So
these are nice for like staggering two transitions. Like if you have one, it lasts a second, you can have another one that starts at the end of that one.
Exactly. And then another thing I wanted to mention is you'll notice that because we have a fixed duration, the transition, I guess the speed will change. So you notice that last one went really fast. That one goes really fast. When the numbers are closer together, it looks like it goes a lot slower because it still is trying to span that full second gap. There we go. That's a slow one. So if we, there's a little hack to get it to like go at the same rate, which we can show right here, which is another kind of feature of the tweened function, which is you can update the parameters whenever you want. So inside of the set, we can actually pass it a new duration. So if we're more curious about a fixed speed, we can tweak the duration every time. So in here, we can compute the duration by looking at the previous value, which is, it doesn't really matter, I suppose, a local value. And then look at the new value, which is value. We're terrible at variable names in these demos. And if we just take the absolute difference, it doesn't matter which direction it's going in. And then multiply.
1 per 30 milliseconds.
30 is our magic number. So now it's going to calculate that on the fly, which means the duration is going to change, but the speed is going to be constant in effect. So now when we do this, that's quick. Let's go slower.
No, that's how many milliseconds per number. So like
longer. Yeah. Okay. So now we can see it more clearly. And even if it's going a long distance, it's going to look like it's incrementing at the same rate.
This is exciting because we never know when it's going to stop.
Yes, it keeps you on the edge of your seat. So that's Tweens in a nutshell. I feel like let's jump over to a way more exciting visual experience and render some dots and maybe also talk about springs. Sound like a plan?
Yeah, I mean, I thought this was exciting, so.
All right, so let's comment that out. And now we have our dot example. So if we look at dots, I guess we have a few extra things in here just to show, but by default, you can see it's still using a tween. It just has a duration here. We have some other things commented out. And then on click, we're actually running this get new dots function, which is really just creating an array of 3 position values. So we have this staggered 100, 200, 300 and 0, 0, 0. Actually, Amelia, do you want to talk? Yes, it's just flipping back and forth between the two. Yeah. So obviously something that's different here is we have an array versus a single number. I guess, do you want to explain that a little bit more?
Yeah, so this is a really nice feature of Tweened is you can either pass a value or you can pass an array of values and then it will tween each of those values. You could also pass an array of objects and it'll tween every single value on each of those objects, which can get pretty powerful. The one gotcha is they have to have the same structure for any update. So you can't have an array with 2 items and an array of 3 items. They have to be the same length and for object shape every time.
Yeah, and for objects, I think it has to have the same like exact structure, right? Like you can't change the properties and stuff.
Yeah, so you might want to sanitize objects. Like I've seen people pass objects with strings in them when they only want to tween certain values, but you'll probably want a specific set of objects just for the tween. You could also just have one object and it'll tween all of the values.
This is all true. So let's make sure this works. So as we click our dots, you'll see we have a nice tween. It goes between the 2 states. Obviously, this kind of shows the thing I was talking about before, which is these all go over the same duration. So they finish at the exact same time. So just another thing to be wary of if you're like hoping that they moved at the same speed. That's not something that's going to happen here. And then we should talk about the dynamic duration, or do we want to talk about springs first?
Yeah, so I think it's also part of the setup is like we have this slider to change the duration, which actually isn't going to work right now for a weird reason. So on line 30, we have this input where you can change the dot duration value, but for whatever reason, the tween will override that whenever you click the button. So we added on line 23 just a way to reset the duration so it's not overriding it. Yeah.
This guy.
Yeah. So now when you update that duration value, it'll take a really long time or a really short time.
Yep.
Yep.
That's probably a good way to segue into spring. So let's introduce spring. So that's the sibling function of the Svelte motion package. I think those are the only two. So if we switch to spring, by default, it'll still work even though if we don't change anything. So let's do that. But you'll see, maybe you'll see, there's a little bit of difference going on here. It has a little bit of a springiness to it, you might say. But that was a terrible joke. I should probably just stop.
We're doing it.
One thing to notice is if we change this, nothing's happening, and it's not because we still have the update happening. So you think that would be doing, but there is actually no duration property with spring. Spring has an entirely different set of properties, which are right here. So if we comment out the duration and we put in this stiffness and damping, we'll see some different behavior. And then we'll try to explain them. So there you go. It's now very different. Those aren't the default values. The default values, I believe, are 0.15 and 0.8. So if you go back to that, it looks kind of just like the normal tweened. This is, I guess, I don't know why these are the defaults, but maybe it's because it has a somewhat like, I don't know, not crazy looking action, but also that could just because of our example. I'll let you talk about some of the spring stuff.
Oh, great. If you uncomment there's some inputs for these, which will hopefully help us feel them out. So we also have these sliders for stiffness and damping. Weirdly enough, they will work with spring and you don't need to reset them in that update function.
Yeah, so that is one of the major differences between the two is if you update the properties like we were doing in the slider, you don't have to, like, it's not going to be overridden when you rerun it, the set. So yeah, I mean, I guess that's nice if you want to do something much more dynamic and like change something on the fly. I guess that would be the use case. But you'll see, so when you lower the stiffness, that's what happens when you raise it. It's just kind of like instantaneous. And then on the flip side, damping, it's kind of like it's the damping. I mean, we both are heavy users of D3 and we use D3 force a lot. So the vocabulary is a little bit different from the D3 world.
I think of stiffness, like maybe you can think of like a string instrument string. Like if it's really stiff, no, I don't think it's the same at all.
Well,
yeah, go ahead.
More stiffness, right, means it's much more rigid, and so if it's super loose, it just takes its time
like a spaghetti noodle. It's like dry spaghetti versus wet spaghetti.
And damping is how quickly it's kind of settling into its final resting place. So, right, when you have more damping, it really settles it down quicker. And when there's less damping, it kind of goes crazy for a while. So, yeah.
For a long time, yeah.
I mean, so yeah, if you go to 0, it can be like infinite at some point.
Yeah, sometimes it just totally messes up.
So
yeah.
There you go.
I'm gonna sit here and watch that.
And there's one other property called precision, which lets you kind of set the threshold for when it's complete. It's kind of like when is it done, the half-life or whatever, done cooling. I'm just throwing out a bunch of different terminology across domains. So that's kind of it.
Wait, I want to see precision. It defaults to 0.01. So what happens if we set it to like 0.5?
So that means even in our crazy world, when this was going like wild, if it like hits that 0.5 threshold, it will say it's finished probably sooner than.
We haven't tested this, so.
Yeah.
It looks pretty normal.
I don't like it.
I don't know what precision is doing.
No, we need some better examples of that. But I think like the difference between the two. So clearly there's out of the box, you're getting way more of this organic, natural looking movement. So personally, if I was doing something where I didn't care about when it finished and it was more just about the look and feel of something, that's when I would choose to use a spring. Do you have any other kind of specific use cases, Amelia?
Yeah, I feel like I use spring if I can get away with it, just because it just feels a little bit more fun. But if I have to sync up multiple transitions, or if I need something to complete in a certain amount of time, or if I want like a staggered delay or a single delay, then I'm going to go with tween, just because it's really straightforward.
Yeah, I think like basically if you need like quantifiable certainty with what's happening, then you probably need something like tweens. But if it doesn't matter when it's done,
Yeah.
or it's nothing else is depending on it, then spring can give you a lot more playfulness and visual options. I guess should we show some examples that were places we've used this?
Yeah, we could do that. There's also, I kind of wanted to show this, but we can show it really quickly. I have this custom tween staggered function that I kind of hacked together. So grab it at your own risk. Tweened in the past, where it has a default duration, but also I delay, which is like a delay at a certain index. So if you have an array, it'll try to stagger it so that like the first one happens more quickly and then it'll kind of be staggered. So this is kind of fun, especially for charts and stuff, if you're kind of like moving something along and it kind of changes in a fun, a little bit more snazzy transition. And like, it's just so easy to use. Like, it's not the fanciest thing in the world, but if I just switch over to tween staggered, it could add a little bit extra excitement into your life.
Yeah, and honestly, this is something that I used a lot when I did D3 stuff. So in D3, when you're doing a D3 selection, so let's pretend you had some rectangles and then you were to put a transition on it, you could put a delay, right? And you would usually say like D, I, and then I is just the order of the element. So you could say delay it by I times 100. And it was really nice because it's kind of built into the framework of D3. So not so much with the tweens here. So that's why you created tween staggered.
Yeah, exactly. Yeah, let's do examples. So this is, the first one's kind of fun. We recently redid our polygraph website and we wanted to play around with dots because they were part of our branding. So all of the pages have dots kind of in the background, but on this page, if you say hover over different names,
there we go. My computer isn't happy.
It's using this tween staggered to move. There's just like several thousand dots on the page in a canvas element. And whenever the tween value updates, the canvas re-renders. So it'll just like have this kind of fun transition for moving those dot positions around.
Yep, love it. Anytime I get to see my cat in dot format, I'm excited.
Yeah, that's how we did it.
And then another project that you and I actually worked on together was this USA Today story, looking at, I don't even remember, this was like 6 months ago now. Wait, almost a year. It was survey data. And so one fun thing we did was there was like these multiple splits of demographics. So you can split by race here, and then you can also split by a secondary dimension. So if we also then split by party, you can see there is this delay in terms of the splitting out. We tried to do this little object constancy so you could follow one at a time to see them split rather than a giant explosion. So that was another place we used it. And again, the code for that was quite simple. It's somewhere here. Oh yeah, so this was using that thing I was talking about before where you can update the properties dynamically. So in this situation, nice comment. I dynamically changed the delay based on the order. So that's how you got that little stagger effect using the tween. So I think that's everything we got for this episode, unless you have any parting thoughts, Amelia.
No, use them. They're great. There's a few gotchas with both tween and spring where like the structure has to remain consistent, and it's gonna throw an error if you like start with a number and then you go to a string, or you start with, I think you can actually start with undefined now, but just like once you understand the edges that you have to be careful of, it's a really nice way to just like throw something in there and then get like animations everywhere. Don't put them everywhere, but use them where they count.
Yep. And the only thing I will say, I haven't looked into deeply into like performance of like Svelte tween versus using some other type of library. So I don't necessarily know if it's the best solution if you're dealing with a decent number of elements, but that maybe is something that we'll tackle in a future video if I think it's worthwhile. But so performance TBD at like a bigger scale when it comes to elements, but on like small numbers, when you have like, especially with like UI elements and stuff, it's a no-brainer.
Although with the polygraph site, there's like 10,000 dots on there. So as long as you're using Canvas, the performance is pretty good. Although it did take a minute for Russell to load that page. And
I mean, I'm also Zoom recording with multiple monitors going, so who knows?
Yeah.
Awesome. All right.
To be continued.
To be continued. Thank you, Amelia. Also, if anyone has questions or suggestions, hit us up in the comments. Until next time. Thank you.